This is a quick presentation that focuses on key calculations in preparation for pre-lab number 5. Well, I'd like to start with the economic order quantity. So in order to reap the benefits of this video, just pull out a calculator or your cell phone, sheets of paper, and a good solid pen. So here we go. Using the economic order quantity, the EOQ, for ordering, establish the yearly demand for chicken breast that is priced at $3.99 a pound, and there's currently 75 pounds in the inventory. The yearly demand for the chicken breasts is about 10,500 pounds of chicken breasts in that year, and the cost for ordering it is $13.25 an hour times 6 hours a month, and the cost of taking inventory is $17 an hour times 15.2 hours a month. Considering all of this, calculate the EOQ. Also to consider, the total inventory cost is $23,768, and there are a total of 376 products in the inventory. So now let's identify the variables in the EOQ equation, which I will assume that you've written down. So the D, the yearly demand, is 10,500 pounds of chicken. That's in a year. The J is the cost of ordering. So that's $13.25 an hour times 6 hours times 12 to get it for the year, and that's $954 dollars, and you divide that by the number of products. So that comes to $2.54 per product. The value, that's the price of the product, is $3.99 a pound. Now E has two components, the insurance and the cost of doing inventory, of actually doing the inventory. So if you remember from Lab 5, the insurance is calculated as the percent inventory. So here we have the calculation for the inventory, $3.99 times 75 pounds, and we divide that by the total amount of inventory, which is 23,768. And then the cost of doing inventory, well, we just basically use the $17 an hour times 15.2 hours times 12, basically to cover the year, divided by 376 76 products, I should say, sorry. All right, now we can see the resolution in orange down below. The EOQ is equal to the square root of 2 times, and now the equation with the numerator and denominator. So let's take a look. So the demand is 10,500. The J is $2.54. So that's the numerator divided by V, $3.99, times E. So E, when we broke it down previously, looked at the insurance and the cost, plus the cost of doing inventory. So that works out to be $1.26 plus $8.25. So now this works out to be then the square root of 2 times, and then we've got it into parentheses. The numerator becomes one value, 26,670, and the denominator, which we identified as basically E times V, is equal to 37.95. So this equals the square root of 2 times 702.77. Once you've completed the calculation, then it's the square root of 1,405.54, which equals 37.49. So I would recommend that students practice this kind of equation, understand the intricacy of each of the variables and how the square root and 2 times the parentheses actually works, right? So what you're noticing here is the multiplication by 2 is at the very end of all the calculations. Now the next problem is really ordering food, and here we have the problem of the intention to serve 3 ounces of steak to 100 people at a large Thanksgiving event. So the question really is asking you, how much steak should you purchase knowing that on average there's 30% cooking loss, that's calculated from the EP amount, and 15% refuse calculated from the AP amount. So AP is the as purchased, this is the amount purchased or delivered by the supplier. EP is the amount left after refuse is removed, and that basically refers to the amounts that go into the recipe. And the AS is the amount served to the customer after the cooking. So the solution can be resolved by determining the AS amount, which we do, and that's 300 ounces. So the goal is to determine the AP amount, given what the as served amount is, which is 300 ounces. So conceptually, I want to bring you to the orange box to the left. And what I'm trying to convey here is how AP and EP and AS actually relate to each other. So AP is at the top, and what we're finding in this problem is that there's 15% refuse. That means a 15% loss from AP going to EP. In other words, EP is really 85% of AP. Fair enough. Then we notice that once we have the EP amount and we start the cooking process, and then we serve, we find that there's a 30% cooking loss. In other words, the AS amount has 30% less than the EP. So we could easily say 70% then of the EP is actually equal to the AS. So if we bear that in mind, we start with the calculation as it appears in the first box at the top. And the calculation begins with 70%, right, of the EP is equal to the AS, correct? And we know that the AS is 300 ounce weight, so we have, therefore, 70% of EP equals 300 ounces, or in other words, 0.7 times EP equals 300 ounces, or in other words, EP is equal to 300 ounces divided by 0.7, which is 428.57 ounces. So now the AP can be determined. So this is what we posit, that 85% of the AP is equal to the EP, and this is because there was a 15% refuse. So this means 0.85 of AP is equal to EP, which we know now is 428.57. We just calculated previously. So AP then is equal to 428.57 ounce weight divided by 0.85, and that's 504.2 ounce weight. And of course the order is in pounds, so you divide that by 16 and you get 31.51 pounds. Now the pricing can be practiced using the videos. I think it's a matter of going over them. I think I would encourage students to review them, do many different types so that you're very comfortable. There's often an error, when you're reading something and you don't practice, you have that sort of conceptual error that you understand. But when it comes to mathematics, you've got to actually practice your hand at doing the calculations. So I encourage the students to do that in preparation for the upcoming quiz. Thank you.